the lines between electrical engineers and mechanical engineers are so heavily blurred that there is no, we don't even think about it that way.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. Modern vehicle design engineers face a ton of challenges, and there's perhaps no one better to talk about that than the global vehicle chief engineer at General Motors, Mark Allen. General Motors, or GM, makes some of your favorite vehicles, including Chevrolet, Buick, GMC, Cadillac, and Hummer. GM is an OG car company and has been a staple in American vehicle design for over 100 years. And Mark joins us here in the lobby to explore the role automotive engineers play and the challenges they face as they engineer new and innovative vehicles into existence. Mark, thank you so much for being here.
Oh, happy to be here. Thanks so much for having me.
Well, it's my pleasure. Can you tell us how you got into the world of automotive?
You know, oddly enough, I grew up right at the corner of 12 Mile Road and Van Dyke Roads in Warren, Michigan, which is right at the corner where the General Motors Tech Center is. And it takes up an entire square mile. So being in the shadow of that fantastic facility that had been around forever, even when I was a kid, and having had my grandfather work there post-war as a prototype welder, getting into that. And he just always talked about what a cool place it was and how fantastic a place it was to work and how they were on the cutting edge. We were always a GM family. I was always mechanically inclined, loved cars, and it just seemed like a natural fit. And going to GMI as for my undergrad and being sponsored by General Motors, that was just kind of an easy in to being part of the auto industry.
So was that something you knew you wanted to do from an early age?
I knew I wanted to go into engineering. You know, I was always enjoyed taking things apart and figuring out how they worked. The move to the auto industry was kind of organic. I was sponsored by an auto company, and then you develop more and more of a passion for it as you get into it. And I've been in it and stayed in it ever since. Never felt a reason to leave.
You said you were sponsored by GM. Were you already working for them, or what did that arrangement look like?
So what is now Kettering University, it started out as General Motors Institute. Then when I went there, it was GMI Engineering and Management Institute. It was a full 5-year co-op program. So we worked for a semester and then we went to school for a semester, and you were sponsored by a company and you always went back to that company and worked all the way through school. I was lucky enough to be sponsored by General Motors, what was Chevrolet Pontiac Canada Group Engineering at the time, which was right at the tech center. And so 2 weeks after graduating from high school, I started my first co-op assignment before ever having gone to college. And that July, August, and September, I worked for General Motors and then went and started my college career after that. And every 3 months, I came home and went back to work.
I imagine the automotive world looked pretty different back then. Can you describe the differences between the automotive industry in like 1985 versus today?
Well, I can describe the culture inside of General Motors. You know, at the time when I joined, General Motors had nearly 50% of the auto segment, and quality and things like that. And we could see that there were competitors that were coming up. There were new players in the market, and they were doing things better in terms of quality and customer satisfaction and reliability. And, we were losing market share, and that cultural shift to we can't do things the way that we've done it before. We have to start keeping up with the industry. We can't just rest on our history and our laurels. That's not going to carry us through. That was kind of when I joined the industry.
Looking at automotive manufacturers' histories and their public perception, reliability comes up a lot. Is there a philosophy of automotive design and development that leads to a better reliability?
I think it's probably more about the execution. Everybody has always known what it takes to validate a vehicle and everything else. It's the attitude to be uncompromising and to ensure that you don't put out a product before it's time, that you hit your milestones and meet your quality requirements. And when you run into something that doesn't work the way you expected it to, you back up, you fix it, and you move forward, and you still work to hit that timeline. But you don't just put something out because our projected date for start of production was there.
I want to circle back to quality and reliability in a moment, but first I'd like to explore some of what makes the auto industry special. Are there any big milestones or technological advances that the folks at GM are responsible for?
Probably more than I can list. General Motors started out, I mean, some of our earliest innovations were the innovation of the invention of lacquer paint, the perfection of lacquer paint versus what Ford was using at the time, which reduced the cycle time from days down to a single day, which also allowed you to make cars in multiple colors where Model Ts only came in black. First mass produced automatic transmission, the first electric starter, first extended range electric vehicle, the first crash test dummies, which have, of course, become an industry and a regulatory standard, the first airbag to be produced into a mass produced vehicle in the 70s. I could probably go on and on, but in both inside the industry and outside the industry, General Motors R&D was responsible for developing the first heart pump that made open heart surgery possible. That particular unit is sitting in the Smithsonian Institution today. The first commercially available room air conditioners developed by our Frigidaire division.
It's pretty incredible what's come out of the automotive industry over the years. That probably explains why some people absolutely love their cars. And I know tech companies with cult followings get a lot of attention, for example, Apple. But I gotta say, car enthusiasts are in a league of their own. Why do you think that is? Why are people so passionate about their vehicles?
Well, the interesting thing about that, the passion for cars, it's not just enthusiasts. Car enthusiasts are kind of a small population. The bigger thing is that the cars are a part of our shared history. They're part of our life. Every time you think back to your childhood and growing up, there's always a car at the center of a lot of your memories. Nobody ever says, remember when we went on that vacation to Yellowstone, or remember when we went on that vacation to Disney. It's always, remember when we all got into the back of mom and dad's Buick Roadmaster and drove 20 hours to Yellowstone. The car is like a family member. It's always a participant in every story, whether it was a family road trip to the Grand Canyon or a group of friends getting together to go to drive 4 hours to go to a music festival. Your first car, the first car you went on a date in, these milestones in your life. You don't have to be a passionate car person, but the memories, a lot of our fond memories of our childhood and growing up and buying our first car, all have a car in the story somewhere. They're an integral part.
As you were saying those things, I was thinking back through the cars that I had during those moments, and I can remember them fairly vividly. Are there any special cars for you when you look back?
Being a General Motors fan, I've always been a fan of General Motors sports cars and our rich history with Corvettes and Camaros and Firebirds. And those always got to me as a kid. The first car I ever earned money for and bought was a Chevrolet Camaro. I always loved Corvettes and always wanted to work on them. Was lucky enough through my career to have that opportunity at various points. Those were always the big ones for me. Everybody had a poster of a Lamborghini Countach, and everybody appreciates the look of a Ferrari. But those were always really key for me when I was growing up, was the local product, the American product.
Ever since I was a kid, I've been fascinated by concept cars. They essentially act as a sneak peek of what future vehicles could be. How much do concept cars actually influence the future line of vehicles? And how much is it just an auto company cashing in on futurism for the sake of PR?
Anything and everything and everything in between. There are concept cars. If you remember in the 90s, there was the Pontiac Transport vans that General Motors made, where the production car was almost identical to the concept car that came out at the auto shows. One of the first cars to have modular seating that you can put in and take out individually, had a lot of great technology in it. And there are other ones that are designed to gauge the perception of the automotive press and the automotive buyer. And maybe you don't come out with that exact car, but it helps to guide your future designs. Big, bold cars like the Cadillac 16 and things like that allows you to gauge whether that concept, whether that idea is worthwhile putting into a future product.
From a design perspective, how do you merge concepts that are cool and unique with concepts that people will actually want to buy?
There's a lot of people and there's a lot of departments that are involved in that, right? when you're working on a particular segment, whether it's an SUV or a sports car or a sedan, we've got our design team that comes up with concept drawings, and then you've got requirements for cargo capacity and people capacity, and there's a push pull of design concept, and we do clinics. You take those rough design concepts, you put them out to people, you put them out to buyers in that segment, and engage their reaction. Does this look fresh? Does this look mundane? And there's an iterative cycle that takes you from your high end vision that maybe the customers don't like your vision. Maybe you think it looks really great and really futuristic, and they look at it and they go, it kind of looks like all the other ones. And you iterate around that until you get something that not only meets the customer's expectations, but will also fit a human in it and meet all those capability requirements. We've all looked at automotive concept drawings that look fast and smooth, and then when you look at the dimensions of it, you can't fit a person in there. So you have to evolve, and
Sure.
and you evolve by going to your customers, and we're not foolish enough to think that internally we can just make those decisions. You've got to put it out to subsets of customers and bring people into clinic and get their reaction to make sure you're on the right track.
On the engineering side, how do teams decide what comes next for a future vehicle?
Well, you've got different things that happen. So we've got execution teams that are working on a specific vehicle for a specific model year, looking toward the future, and then we've got teams that work in specific areas. We have a chassis organization, we have an interior organization, we have an electrical organization, and they're working on the future systems, maybe not necessarily targeted at a specific vehicle. So a future infotainment system that once they define what that is, then we'll start thinking about when do we roll that in as these vehicles are in their development cycle.
It sounds like a pretty aggressive strategy to develop tech without a specific vehicle in mind. Surely some things are developed just for one model?
The Corvette program does this quite often. They will develop a future technology integral to the launch of that car. But in our mainstream scenarios, they often happen in parallel, and then you drop them in. And so when you think about what to drop in, it really depends on, well, what's the segment of that car? What's the customer expectation of that car? What's the price range of that car? Does the Chevrolet Sonic or Chevrolet Spark buyer, the Chevrolet Spark has an initial MSRP around $13,000. Are they going to expect Super Cruise, technology? Can they afford that? Does that align with what that vehicle segment and expectations are? Right now, probably not. And so you try to align those with the customer expectations for every segment and fundamentally the price point. You have to be aware that some technologies that start out as in very high-end vehicles in just a short couple of years become ubiquitous and expected, even down in the lowest segment of vehicles. And then in some cases, they become regulatory. Backup cameras is a perfect example. Went from a high-end luxury item to expected to regulated in a very short period of time.
Like 10 years or something like that. It went from, what is that, into it has to be there.
Right. And then you also have things like consumer electronics shows that happen iteratively through our cycle. And things that might not have been on the drawing board when we started become expected in the public and in the industry before we get there.
We'll be right back with Mark Allen. This podcast is sponsored by EBV Electronic. Silicon carbide and gallium nitride, what are these new materials and what are they used for? The latest episode of the Passion for Technology podcast introduces the world of silicon carbide and gallium nitride semiconductors. What are these new materials and what are they used for are just two of the questions answered by interview guests Lisa Dietrich, Senior Industrial Field Application Engineer at Broadcom, and Carl Lenhoff, Director of the Industrial Segment at EBV Electronic. Listen now on ebv.com. And now we're back with Mark Allen, GM's Global Vehicle Chief Engineer. Mark, electrification of vehicles has been an incredibly hot topic lately. What's the automotive industry's perspective on it?
It's going to be interesting. And I think for a long time, everybody has known that we've been on a journey, even before it became mainstream. You go back 20, 30 years, everybody knew that the end game was going to be some sort of electrification or non-fossil fuel based propulsion. The only question was when. When do you start to make that move? And I really appreciate having leadership in the company. When Mary put the goal out there that our ultimate goal is zero crashes, zero emissions, and zero congestion, it's not achievable today, but it does give you your endpoint and it does give you what to strive for. The customer acceptance of electric vehicles, we know it's going to get there. The timeline that it gets there is going to be dependent not only on the industry, but also outside factors, government and federal support of our electrical grid and fast charging stations on the interstate highway system. How that rolls out will directly correlate to the acceptance and use case criteria of the customers. And so we'll see how that evolves. It seems like everybody's in. The government's in. I know that mass charging stations are part of the infrastructure bill that was just approved. And so the expectation is that we're on that journey.
You mentioned Mary Barra. She's an electrical engineer.
She is.
Are there any advantages to having an electrical engineer as your CEO?
The thing about her is that she came up through the General Motors ranks with everybody else. She is one of us, as opposed to being somebody that comes in from the outside that maybe knows the industry, maybe doesn't. She's done every job. She understands what everybody faces, from the lowest levels of the company to manufacturing to HR to engineering. And so we all speak the same language. And that is what is really appreciated. She knows it all. She's done it all. And that really helps for perspective. And then, of course, she's got some bold vision that we can all rally behind. We trust her.
That means a lot, for sure, to have someone who's worked their way up and knows what's what.
And of course, her double E background certainly helps with all of the electrification, not even talking about electrified vehicles, but just all of the electrification within the mainstream vehicles. She understands it.
Having that engineering perspective must be super valuable. Looking at automotive applications, one element that stands out to me is durability and life cycle. What's the expected life cycle of a vehicle, and what factors play into those calculations?
We have very specific validation cycles, and we've got durability requirements that some of them are on emissions control systems and things like that are federally mandated. There's no reason why vehicles can't live for 15 years and 150,000 miles. However, where we differ from something like a cell phone, no matter how well you take care of your cell phone, it will become obsolete before it could reach the end of its useful life. With a car, depending on whether you live in Arizona or whether you live in northern Michigan, whether they salt your roads, don't salt your roads, do you wash your car? Do you keep it in a garage? Do you keep it out in the weather? How well do you maintain it? How often do you change your oil? Cars can have a ridiculously long life. The real interesting thing about being in the auto business, and what makes it so much fun as both a mechanical engineer or electrical engineer or anybody, is the consumer's expectation. With electronic devices, whether they're computers or your cell phones, everybody kind of gets used to it glitching. You turn it on, you turn it off, something like that. A car, on the other hand, with all of the parts that come into it, if it's minus 40 degrees out and you live in northern Minnesota, you expect to push the button or hit the key and that thing's going to start. And if it's 130 degrees and you've stopped at the bottom of Death Valley, you expect that thing to start and run under every circumstance, every time, every day, not strand you. So we work in an industry where the customer's expectation, not only for its basic use for transport, but also to keep them safe and everything else, is ridiculously high. And that makes the work really exciting.
Can you share any extreme weather scenarios from product testing?
Well, I was fortunate enough to, at one point in my career, I was doing calibration work on engines, and the work that I was doing required me to be a part of the group that went to all of our extreme conditions. And that meant that we were doing work in Arizona and in Death Valley in July and August. That meant that we went to Kappas Casing in Ontario, which is about 800 miles due north of Detroit. We went there in the winter, and we'd go to altitude development in Colorado. But one of the things that was really funny is it would be minus 30 degrees out in Kappas Casing, and that wasn't good enough. If it wasn't minus 40, it's minus 30 out, and we would take our vehicles and pull them into chilled, cooled freezer garages and park them in there to get them down to minus 40, because the ambient temperature at minus 30 or minus 35 wasn't cold enough. And we were testing to make sure that that car with an 80% state of charge battery would start and crank on the first attempt and then drive and not stumble and not stall. But yeah, minus 35 wasn't cold enough. We need minus 40, so put it in the refrigerator.
And I would say, can you convert minus 40 from Fahrenheit to Celsius or back and forth? But that's actually the inflection point where they're the same.
It's the inflection point, yes.
I remember driving, I'm based in Colorado, so we often see people doing altitude testing. I remember driving through a cold basin, and we're like, man, the heat's kind of high. And we looked at the temperature, an old Suburban, minus 39. It's like, okay, we had to stop for gas and turn the car off. And I was like, well, I hope it starts up again. But sure enough, it worked.
We would spend time up in Frisco and park vehicles up at Loveland Pass. So you could do a cold start at 10,000 feet. We'd drive to Leadville and make sure that a hot restart after a 20-minute soak at that altitude with that fuel, that it worked. Because the consumers in the area, that's all they know. It can't stumble, it can't bog down. It has to work under all of those conditions.
Do you have any testing horror stories or issues you caught while doing these tests?
Oh, it's too numerous to list. I mean, there are use cases when you drive around the country, particularly if you go down to Arizona. It could be 90 or 100 degrees in Phoenix, and you would buy what is fundamentally summer gas, right? So it's got a low Reid vapor pressure. It doesn't flash off very quick. And then within one tank of gas, just a 2.5, 3 hour drive, you could drive up to altitude still in Arizona, and your next start the next morning would be at around freezing, at around 32 degrees at altitude up in Sedona and areas like that, with that same summer gas. And that's a valid customer use case, making sure that it didn't stumble, it didn't falter in a very valid environment that a typical customer would do.
So are you like a gasoline sommelier?
I didn't know until I worked for General Motors, till I worked in the auto industry. I didn't realize that the fuel you buy at the pump changes depending on the season.
So other than being able to tell what region of France a particular vintage of gasoline came from, what skills make an engineer successful in the automotive industry?
There's probably two. And one is, I've mentioned this a couple of times, knowing your customer, knowing what you're doing and why you're doing it, putting the customer at the center of what you do, and then understanding what you're engineering toward, being uncompromising in terms of your principles and making sure that it meets those requirements before you're done. And then on the other hand is the converse of that. As engineers, we're all scientists. The rock can always get smoother. It can always get a little lighter. It can always get a little bit more efficient. Also understanding when to stop, because engineers will never stop. We can always evolve. And the quality of the vehicles in our industry is proof of that, right? But being able to stop for this year and go, I've done what I needed to do. I've met my design mission. Now I move on to the next year. But you have to really understand what you're doing and why you're doing it. And it's not a science product. It's not a science project. It's a consumer product, which means you do have to go to market.
So how does cost play in then to design decisions?
Oh, it's almost the beginning and the end. I mean, to quote training that you'll get if you go to the Disney Institute, we're a for-profit business, right? So every vehicle has a segment, and that segment has an expected cost, and that vehicle has to make a certain amount of profit and carry its burden. And when you dial all that out, you're left with a number that is fundamentally your material cost. And then you have to engineer to that. So depending on the segment you're in, sure, we'd love to have magnesium control arms on everything, but maybe that only makes sense on a product where one of the primary drivers is weight and performance. So we have to get very specific about engineering and engineering for efficiency with lower cost materials based on the segment. If it's a Chevrolet Malibu or a Sonic or a Spark in an entry level segment, we don't have unlimited costs. We don't have unlimited room for technology. So we have to be very efficient in design and yet still make it a cutting edge product. And that is that interplay between the two provides a lot of engineering freedom and creativity opportunity.
Speaking of targeted focus on cutting edge tech, you were involved in one of the first hybrid trucks. What were some of the things you learned and developed while doing that project?
A couple of things. The first truck that I worked on was our parallel hybrid truck, which had moderate electric assist. We basically invented designs. The stator, ran on the inside of the bell housing of the transmission, and we made a small torque converter, and the rotor was around the torque converter. It was a 7,200 watt generator, in addition to being a really powerful electric motor. And it allowed us to help develop not only the technology for that, but the software on how to control it. And then that evolved into belt alternator starter systems, which were far more efficient and smaller and lighter and more cost effective. But the software control that we developed on that bigger truck and that first truck helped with start-stop systems, understanding the control and the customer expectations around start-stop systems, which have become completely ubiquitous in the industry. You can't hardly find a car without them.
Quick note from the editing bay. As you can tell, Mark's dogs, Shotzi and Nala, are both pretty excited about automotive engineering. We did our best to keep this podcast in English, but in a couple spots, the pups couldn't help but chime in with some extra context for our canine listeners. Things like, which GM drivetrains are best for hanging your head out the window, and who's a good girl? Shotzi and Nala, that's who. For the human listeners, sorry for the barking. I'd translate for you, but I don't speak dog. Now back to Mark, Shotzi, and Nala on developing one of the first hybrid trucks.
Developing the control algorithms, in addition to the technology at low volume, allows you to then roll it into high volume. We had also developed a two-mode hybrid truck, if you remember, and we put it into Tahoes and pickup trucks, which had the two motors in the transmission. It was a wonderful piece of technology ahead of its time, but it allowed us to develop the engineering principles and learnings that then evolved into cars like the Chevrolet Volt, which will now evolve into the Bolt and the electric vehicles that are going to be far more mass-produced and widespread.
How much software goes into a hybrid or electric vehicle?
We're talking about, in any vehicle, millions and millions of lines of code. It's almost unimaginable. I can't name a number, but there's software everywhere in the vehicle. It's in your HVAC system. It's in your engine control. It's in everything. And if you think about it fundamentally, you've got this module-based electric systems, because with all of the systems in the cars, if everything was pin-to-pin wiring and discrete switches for everything, you'd have a wiring harness the diameter of a bowling ball. and you can't pass that around a car. So we've got to get, you've got to modularize that, and then you've got to get very efficient with your communication systems in order to have a high-speed bus to pass information back and forth between all of those modules. It's more practicality than anything else.
Looking forward to autonomous vehicles, it seems to me like those communication systems and data rates are mission critical for success.
Certainly. Everything that's coming from all of the sensors on the vehicle to the control, it's all about that passing of information.
A Bloomberg study suggested that roughly 40% of the cost of a new car is electronics. Does that ballpark check out today, or is that off base?
The problem is it's one of those equations that it's almost difficult. If all you did was count up the number of controllers, you might come up with one number. But if I then roll in just the switches that you see on your steering wheel, well, those aren't discrete pin-to-pin momentary contact switches. They're all multiplex switches. So now are those electronic components, because they've got a small board and a tiny bit of logic. If you start to roll in all of those things, you can vary the number extremely widely. The bottom line is there are very few, if any, purely mechanical systems left in the car today. Everything at a minimum is electromechanical or mechatronic.
As the technology has shifted into that hybrid approach, how did the historically mechanically minded engineers react to the increased electrification and digitalization of vehicles?
It's funny, and I know that this isn't a double E based podcast, but all of us cannot operate in purely the electrical or purely the mechanical. And so, me as a automotive engineer or a mechanical engineer for my undergrad, very shortly into my career, I found myself doing calibration for engines. We didn't have carburetors anymore. It was all electronic fuel injection. All of the code was written in assembly language, and I found myself a year out of college taking a microcontrollers course so I could read, understand, and write assembly code. So the lines between electrical engineers and mechanical engineers are so heavily blurred that there is no, we don't even think about it that way. I will say that at least when I was going to school, I think the double E's had an advantage because they took so much more. They took more of the core ME classes freshman, sophomore year. They all took physics and mechanics of solids and statics and dynamics. And we took circuits and then maybe an optional class. And I think I took digitals, something like that. So the double E's coming out were probably better equipped to play in both spaces than the MEs were.
Is there anything that the double E's do or miss that drives the mechanical engineers crazy?
Not that I've seen, because we're so fluid in our spaces, right? At one point in my career, I had responsibility for all of our shifters, that shift the gears and transmissions, and I had responsibility for that group globally. And we had some shifters that were pure mechanical components, but they still had electric switches in them. And at the same time, we were developing electronic ETRS, electronic range select, that you've seen in quite a few more cars with levers and buttons and dials. And the same group of people were developing those components, which had a much heavier electronic influence, and they had software that controlled them. So the lines are so very fluid between electrical and mechanical engineers. And sure, we have guys, electrical engineers, that are doing pure circuit and code in that design, but in a lot of the areas, it's just very fluid.
Is there anything in the automotive design that feels like it's harder than it should be, or people look at it and say, "Oh, that's so simple," but is actually just way more complicated than people understand and recognize?
Oh, I think almost anything. I think if you look at anything from, I mean, even just look at the interior design of a car and the aesthetics around it, and most people don't realize that all of those materials in all of those areas have radius requirements and softness requirements for crash testing and things like that. So in addition to just drawing a picture and then executing that design, you also have to take into account all of the potential places where that sharp edge could come into, it could interact with the airbag, and it could also interact with the occupant's arm or something else. And that doesn't mean that you can just make things all round and smooth either, because those components have to interface together. So the interplay between components and systems, you can't just say, well, when do you guys think about safety? We don't ever not think about safety from the very beginning of the concept all the way through the aesthetic design. When do you think about quality? All of it is from the beginning through to the end, and they're all intertwined and almost inseparable.
So you mentioned safety. You have an extensive background doing safety eligibility and making sure that the GM products meet, especially like European requirements. How many different specs and requirements do you have to worry about, and how do you go about making sure you're not missing something somewhere?
Never is anything the responsibility of one person just to follow the steps and they miss one. We make sure that we check ourselves at key decision points throughout the design development process, so we don't get ourselves into a hole that we get too far down the road and we find out we missed something.
Is there anything you've been a part of on the safety side that you're particularly proud of?
Yeah, our even from a you don't think of it as a safety system, but I talked about our electronic transmission range select, being able to put the safety umbrella on top of that to where if a customer forgets to put that car in park, that when they shut it off, we're going to put it in park for you. If they open the door and unbuckle their seatbelt, we're going to put it in park for you. We're going to make sure that that car doesn't roll away on you in case you make a mistake.
Are there any features that were particularly poorly received at the time but are now just normal and expected in vehicles?
I'll give you an example, and I'll go back to our electronic transmission range select as just an example. We had several different executions, right? We had a lever on the console, we had buttons, and we had an auto writer that looked at one of our cars before it was released and looked at the buttons on the center stack and essentially poo poo it a bit. Oh, that's not going to, I don't like where it is. That's not going to work. And then after the car was released, there happened to be one of the writers that had an opportunity to embed in that vehicle for a couple of days and drive it and spend some time with it. And he came back out in the article and said, it just works. I was wrong. It just works. It does what it's supposed to do. And I don't even need to worry about it. And ideally, in some of those systems, you want to be like the umpire in baseball. If nobody knows you're there, you've done your job.
I'm constantly and pleasantly surprised how impactful a user experience engineer can be on a final product. It's really one of those make you or break you type roles. And I feel like it totally reframes how users think about the end design.
Yep. I want people to comment on how comfortable the car is and how well it drives and how powerful the engine is and how fuel efficient it is. The ancillary systems, I don't want them to comment. I don't want them to say, oh, gee, it was so easy to buckle my seatbelt. They're not supposed to comment on that. It's supposed to just work. And so those ancillary systems, if they become invisible, then you can be very proud quietly that you've done a good job.
So no press is good press sometimes.
And with some systems it is, right? And then there are, the hero parts of the car. A perfect example is the new engine that's just been announced and released with the announcement of the Corvette Z06. That's a team that can take a hero lap around that wonderful piece of engineering technology.
Have there been any vehicles or projects that are extra special for you?
There's always ones that you got to work on and then you were there for their debut. I was there for the debut of the C5 Corvette, because we worked on the engine. And it's always particularly fun to be able to drive one of those homes just as they're being released or right before they've been released, but we've pulled the camo off of them. I was involved in the initial release of the fourth generation Camaro Firebird and getting to drive one of those home. But I tell you what, working on the products that I'm responsible for today and driving home a Chevy Blazer right after it was released and having people stop you and just comment on how beautiful the vehicle is and how much they love it, and then seeing them all over the place, that brings a particular piece of pride. And it doesn't happen all that often, but several times during the year, we will get an email from somebody that has been in a car accident, not of their making, but a tremendous car accident. And the letter is always the same way. This happened, and here's the picture of my car, and myself and my wife, or myself and my kids, or myself and my husband walked away without a scratch. And that always brings a particular piece of pride to you. I just got one last week of a Chevy Blazer that was in an accident, and the person took the time to write to the company and just say how thankful they were that the car kept them safe through something that was completely out of their control. That's really where it gives you the feeling that you're on the right track, and we are putting the customer at the center and doing the right thing.
On your LinkedIn page, there's a classic Corvette. Is that yours? And can you tell me more about it?
There is. It's a 1961 Corvette with a 283 and dual quad carburetors and a manual transmission, and it is absolutely a thing of beauty. And that's something you talked about, the passion for the auto industry. Even if you're not a car nut, if you look at a car like that, people want to see it. They want to sit in it. They want to ride in it. And on a Sunday afternoon, when the weather's nice and the top's down, it's just an absolute joy to drive.
One of my coworkers got like a mid-90s Grand Touring Corvette, like the blue one with the red leather seats.
Uh-huh.
And
Yep.
he says the kids in the neighborhood go crazy and the adults all try to pretend they're not, but everyone seems to be a big fan.
That is an absolutely gorgeous color that was on. It was the Grand Sport
Yes.
Corvette, the blue with the red interior and the white stripe down the center. Is just an absolutely gorgeous car.
In popular media and sci-fi, are there any cars that everybody just goes, oh yeah, like the DeLorean from Back to the Future or anything like that everyone just kind of knows and recognizes as a piece of spectacular fiction?
Oh, there's a number of them. There's the Knight Rider Firebird, the Kit car, and there's been all kinds of cars. The Ferrari from Magnum PI and cars like that. There's a lot of inherent. I mean, even the concept vehicles and the crazy vehicles that were part of different TV shows. But it's part of that, like we talked before, associating cars with your childhood and with milestone events and with TV shows that you particularly liked. It's always really cool.
And then a prediction for 2100. What would a car look like? What can we expect?
I'm pretty sure in 2100 it won't be powered by an internal combustion engine. But I think the transportation industry in and of itself is evolving, and it's going to be really interesting to see where that goes. I mean, when you talk about autonomous vehicles, you're talking about, in a lot of cases, where you probably don't go buy an autonomous vehicle and park it in your garage, that you participate in a service and you call it when you need it. So it'd be really interesting to see what personal transportation looks like in 100 years from now. And will we all still have a conveyance in our garage that we own and drive? Not entirely sure that we will.
Some very interesting parting thoughts for us there. Mark Allen, Global Vehicle Chief Engineer at General Motors, thank you so much for being here. It has been a blast.
Thank you. It was an absolute joy. Thank you.
Thanks everyone for joining me today in the lobby. If you liked this episode, let us know on the All About Circuits social media or leave a comment on allaboutcircuits.com, and then go tell a friend about this podcast and get them hooked on it too. I'm your host, Daniel Bogdanoff, and I'll catch you next time.
Take the regulations and they develop those requirements. My iPad was listening to us.
Oh, you're fine.
I'm not sure I understand.
The beauty of recording and editing.
Yeah, exactly.
That's what I reckoned.
She's still awake. Stop it.